Hi everyone, welcome to Math Homework channel and more review on AP Calculus. Okay, so let's see that problem. He say let R be the region bounded by the graph y equal 2x and y equal 4x minus x squared. What is the area R? Okay, so apparently here we have two graphs. Y equal 2x and y equal 4x minus x squared. So this is like a linear function and this is a quadratic, a parabola. Okay, so let's just get an idea of how this graph looks like. If we try to graph this, so y equal 2x. So the first one, y equal 2x. All right, so when y is 0, x is 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So so this is 0, x, y. Say when x 2, y is 4. 1, 2, 3, 4. All right, so this is all right. We can do better than this. So when x 2, y is 4. And then we just okay, so this is y equal 2x. And then the second one, this is proper. So when x is 0, y is 0. So that's the first intercept point between the two functions. And then, so this is 1, 2, 3, 4. 1, 2, 3, 4. All right. Then when x is 2, so go to this function here. When x is 2, y equal 2 times 2 is 4. 2 times 4 is 8 minus 2 squared is 4. So this is be 8 minus 4, so it will be equal 4. Okay, so x2 equal 4. So this is second point here. So if we complete the graph, substitute for different value, this function, it will looks like this. This 4 here. And he wants to know this area here. So we can call this R. Okay, so this function, this one is y equal 4x minus x squared. So to get the area between the two curves, that is, if we remember the integration. So first we have to find so this all right, this is about okay. So first we have to find the point of intercept between the two functions. When this happened when the two functions basically equal each other as this two value, which is x and y here and x and y here. So we're going to make the two function equal to each other. So we can say 2x equal to 4x minus x squared, right? Then we can just subtract 2x from both sides. So 4x minus 2x minus x squared equal to 0. 4x minus 2x, that's 2x, minus x squared equals 0. So we can take x as a common factor. So it will be 2 minus x equals 0. So that means x equals 0 or x equal 2. So this is the two value, x equals 0 or x equal 2. That's the two value when the function equal each other. So what's the y value for this? So when x equals 0, we can substitute in either equation. We're just going to take that one here. Substitute. When x equals 0, y equals 0. When x equals 2, y equals 4. So that's the value here. There's 2 together, 0 and 0, and 2 and 4. All right. So now we need to know the area between the two curves. So this is the top one, and this is the bottom one. Top one is 4x. So we can say the area, which is r, that's the area, equal to the integration from 0 to 2, 0 to 2, because this is basically the part of the two function we concern about, where both the intercept throw. So the area from 0 to 2, that's my interval here, and then we subtract both functions. So it will be the top function, which is 4x minus x squared minus 2x, and that's dx. Okay, let's simplify this. So equal 0 to 2, 4x minus 2x, that's 2x minus x squared dx, which is equal, what's the integration of 2x? It's x squared over 2, which is going to be x, minus, what's the integration of x squared? X cubed over 3, all this integration from 0 to 2. Okay, let's substitute this. Equal 2. So this is going to be 4 minus 2 times 2 times 2. That's 8 over 3. That's the first substitute for 2. Then minus, substitute for the 0. So it will be 0 minus 0. So basically the second term is 0. And then this term will be equal. Take the 3. Two times 2. Take the 3, common denominator. So it will be 12 minus 8 will be 4 over 3. So that's my R here. That's the area for the region bounded by the two function. All right? Okay, so that's for this problem. Let's have another one. Let's have another problem on this. He said this one is integration. So integrate from -1 to 1 x squared minus x over x dx. Okay, let's simplify this. So integrate -1 to 1, take the x common factor. So it will be x minus 1 over x dx. this 2x will cancel out. So it will be equal -1, 1, x minus 1 dx. So, okay, what's the integration? X squared over 2 minus, what's the integration of 1 is x. And then integrate interval from -1 to 1. Okay, let's substitute. X squared, 1 squared is 1 over 2 minus 1 minus second interval. This is the same. Minus 1 squared is 1 over 2 minus 1. Okay, so that will be equal -1/2 minus 1/2 plus 1 equal -1/2. So this is 1/2, that's 3 over 2 minus 1 1/2, which is 3 over 2. So it will be equal to okay. So this 1, let's review here. This is 1 squared. Okay. So 1 over 2 minus 1. Then minus minus 1 squared. This is 1 over 2 minus x minus 1. Okay. So this will be -1/2. Then minus 1/2 plus 1, that's 3 over 2. So it will be 2 minus 4. So it would be -2. All right. So that's the integration for this one. Okay, great. Let's have another problem. Next problem is to say which of the following interval must there a number c such f dash of c equal to. And then we have a table of intervals here. Okay, we got 6. 1, 2, 3, 4, 5, 6. So this x, this f of x, and then we have 0, 4, 8, 12, 16, and the f of x is 8, 0, 2, 10, 1. So it wants to know which interval of those interval such that function of c equal 2. All right? So this one we're going to use the mean value theorem. Okay, what's the mean value theorem say? It said f dash of x equal fx2 minus fx1, function at point 2 minus function at point 1, x2 minus x1. Okay, and we already know, it's a given, that f dash of c equal 2. So let x2 equal 12. So we're going to pick the 12, and x1 equal 8. So next to 12, what's f x2? It's 10. And fx1 is 2, right? So let's do that. So this two together, right? The opposite. So it's opposite. And this match this. Okay, so we already picked this 2 point. And let's substitute for this. So f, all right. So we say f dash of c is equal. So what's f2 of x? fx2, 10. What's fx1? 2. Over. What's x2? It's 12 minus 8. So 10 minus 2, that's 8 over 4, which is equal 2. And that's the value, which is a given value for fc. So that means interval 8 and 12 is the correct interval such that the fc will equal 2. Okay, so we know the interval is this interval here. Okay, and that's it. There you have it.